So I'm standing in front of one of our 16-inch products. Hollow, hollow, solid. Why solid? Why is this so important? And how do we do this? How do we fill this core solid? That's what we're going to find out today and what we're going to talk about. Across the bottom, we have a steel strand that's been pre-stressed. And we've talked about pre-stressing and how that's important to carrying the load, so that when the load rests on top of the hollow core, the strand that's been held in place by the concrete is compressing the bottom of the element, the bottom of the slab, so we load it and it's carrying that load. So you're getting some load carrying capacity and tension from the concrete, but a lot of it's coming from the steel. And if you think about it, basically this is an I-beam. So if you know construction, we deal with I-beams a lot. Half of this flange, top flange, goes to this middle web. And it's this web that is helping to transfer the load from above and then down to the bottom. Occasionally though, these webs, if you will, are not enough to transfer all the load, particularly in shear. This is shear, tension is pulling apart. We're talking shear. Shear generally happens more at the wall and where the hollow core element rests on the wall or on a beam, because there's more load and it's trying to shear the pieces apart. As opposed to in the middle, if you have two walls and you got your hollow core running from wall to wall, in the middle you have more tension. So we're going to fill this core solid for 2 or 3 reasons. 1, shear. 2, it could be a weld plate underneath. And in fact, on this one, there is a weld plate. And that weld plate is used to connect to the beam. It's going to be welded to the beam. And that connection is critical for transfer of load from the walls and the loads coming from above, down, and through the floor system. The other reason that this may be filled solid is we sometimes will cast in additional steel, additional rebar, maybe up on top, maybe on the bottom for additional load carrying capacity. So filling these cores solid is a really important process to the hollow core system. It allows us to continue to carry exceptionally high loads from above and still maintain the clear span that we want underneath. It's why the hollow core system and the podium systems of beams, columns, precast, and the hollow core are so widely used today for apartments, senior living, student housing, multifamily condominiums. I mean, you name it, and this product is being used all around the United States. I'm here with Matt, with Corey. What is this thing hanging in midair?
Sure, this is the grout hog. So it holds about 2 yards of concrete, and according to the program, punch holes, and we fill with concrete.
You know, and the importance of filling the core solid is so it's increased shear for load carrying capacity. So what happens is we get a load, like a wall or a point load, on the hollow core, on the floor system, and it needs extra shear capacity, load carrying capacity. So Matt, when we're filling the core solid, I know sometimes we do it for shear, but we also do it for what other components?
Well, some programs we're running weld plates, top and bottom.
Right.
You know, when we have to strip the beds, we have to lift some of the pieces off the bed.
So we got lifting devices that are being anchored in this concrete in the solid core.
Same thing with weld plates. You know, we have to, like I said, top and bottom.
So this is a really good example of a hollow core slab that has multiple holes in it that we've had to break out. So we're going to fill this solid for shear, and you can see we're actually also holding a additional rebar in the top. So there's probably a cantilever condition, like maybe over a balcony or extending out to create some architectural element that needs the additional load carrying capacity in steel on top as well as throughout the entire element. So not only do we have the pre-stressing strand running through the bottom, we're adding rebar, additional steel reinforcing for tensile strength on top of the element. So for now, because these outside cores are still a little wet, we're just going to pour the center. As I pour the concrete, Corey comes up behind me and gives it a nice finish. One of the things that they do ahead of the filling process is they use this plastic cap and they'll stick it down into the core so that when the concrete hits it, it stops and it doesn't fill the whole core up. So a quick example of where we've had a solid core filled is right here. And what you can't see in the camera, but what I know to be true is underneath here, there's a weld plate. So now we can see this weld plate that's been cast into this concrete. It's sitting on the bottom of the bed. The wet concrete that comes out of the grout hog is filling this in. Now on this plate, there are a couple studs that are tying this plate into the solid core. And the same here, so there's two of them. Again, those connection details are important for transferring loads between the floor system and the beam and column and post system, or a wall. The complexity of how loads are carried throughout a building are why we have really smart engineers and designers. Thanks for joining us today from our hollow core manufacturing plant, where we're talking about shear, load carrying capacity, precast podiums for underground parking structures and multifamily uses, office uses. Again, we're just seeing so many projects working with our hollow core product, providing for that sound resistance, that high load carrying capacity, long clear spans, fireproof mechanisms and systems. Thanks everyone.